Hi, today we'll be going through pressure. And so basically for pressure, pressure is this item where it is actually a force acting perpendicularly on a unit area of surface area. So in other words, right, let's say you have a particular area of surface, which is highlighted in green. Okay, the pressure is actually the force that has to act perpendicularly onto the area, the one that is highlighted in yellow. In and this is usually happen, right, if let's say, right, you are actually on a surface or on ground or mainly on a, like a solid plane. There are of course other ways to calculate pressure other than this formula, or pressure equals force over area. There is a pressure in a liquid and a pressure in gas, which can be calculated in other means. But in general, basically pressure is this force acting perpendicularly on this unit area of a surface. Now, in this case, right, one very important thing that we need to know is what is the formula, what is the units of pressure? Because having standardized unit will determine what kinds of other relevant units will be needed to be converted to for your calculation. So in this case, for pressure, when it's Newton per meter square, okay, or you can put it as n slash m square. Okay, what happens is the slash represents the divide sign, and therefore force, the SI unit for force is in Newton, and for surface area is meter square, which is usually calculated by length times breadth, or if let's say it's another kind of surface, then the area formula. Now, what are some things that influences the magnitude of pressure? When we talk about magnitude, we are talking about the strength of the pressure. So number one is having force. That's one way. The other one is the area of contact. Area of contact, meaning the one that is actually um, that is that's actually affecting the pressure, the force. So when we look at this, right, we actually look at two things so that can influence, that can affect pressure, in the sense that when the force increase and the area remains the same, okay, this will result in your pressure to actually increase. Because the numerator increases, this will lead to the pressure also increase. On the other hand, if let's say the area increases, whereas the force stays the same. So you are actually dividing a larger number, resulting in the overall, which is pressure, to actually decrease. So this will actually mean a few things. When force increase, acting on a particular on the surface, this will actually lead to an increase in pressure. Of course, you decrease the force, your pressure will also decrease. So they are actually directly proportional. However, for the area, they are inversely proportional in the sense that when area increase, pressure would decrease. When the area decrease, the pressure would increase. So this is one thing where we can see of how the factors actually influence the magnitude of pressure. So one way to look at it when we talk about force, right, you look at the gas particles when they are hitting against the walls of a container, right? As the particles hit even more forcefully, the pressure will increase. And of course, when you reduce that area, right, in which, so let's say you have a container, and when you make it smaller, okay, but the particles will still be there. The same amount of particles will still be there, which means that the frequency of the particles hitting against the container surface, right, would actually increase. That would indirectly increase the pressure. So for pressure, right, it's like an understanding of how these particles are hitting continuously onto its container wall. Okay, so that's one way. Of course, another SI unit for pressure is your Pascal, which is directly the same as your Newton per meter square. Okay, now, in our daily lives, we usually see pressure acting on it quite frequently. For example, in terms of the knife, boots, or even skis. So knives, right? Generally, when you have a chopping knife, okay, usually what happens is the knife is actually very thin, and this thin will actually add on to being having a lesser surface area of contact when you want to chop something. This lead to an increase in pressure so that it's easier for you to cut. Okay, for boots or even skis, in order for you to have to be more stable, able to, let's say, not fall into the snow, what you can do is you actually have a very large base area. This will actually help to distribute your force on every per unit area available, and hence resulting in pressure to decrease, so you don't really sink down directly. Okay, so an example of a question that will test you on the concept of the formula pressure equals force over area is that, let's say you have a tank of length 3 meter, width 1 meter, and a height 0.5 meter. The diagram here actually showcases a pictorial form of how the measurements are, and they are filled with liquid which weighs 12,000 newtons. This weight is indirectly telling you the force. Okay, and another way you can look at it is the Newton. So calculate the pressure on the base of the tank exerted by the liquid. Now they are looking for pressure. So again, writing the form, first you find the area of contact. Where is the tank placed? So the one in red on the diagram shows you where the surface of contact we are looking at. So it's 3 times 1 meter, which is 3 meters square. We have the force, and therefore pressure is just force over area, which is 12,000 divided by 3, you get 4,000 Pascal, or you can say 4,000 Newton meter square. Okay, Newton per meter square. Okay, so this is one area of looking at it. The other aspect to it is, let's look at pressure in liquids. So for pressure in a liquid behaves very differently on land or on the solid. Okay, so a liquid exerts pressure because it has weight, and being weight, you are actually indicating that it has a force. So the pressure at any liquid acts at any point in a liquid acts in all direction, because you can't really dictate where the particles are flowing, just like in a gas where they are just free floating. Okay, and that they are usually pressure is actually the same at the same level of a liquid, and it's not usually affected by the shape or size of the container. So because for liquids, right, they come in non-definite shape. So what actually cause it to be consistent, right? In that case, right, it's usually the height of the liquid. Okay, so let's say we look at this condition, regardless of where the liquid is, or the container shape, we will see that the length of all the liquid, right, will stay the same. That's one. So if, let's say, I were to throw a ball, okay, they will end of density and things like this. We always thought like, oh, the pressure will actually affect the density. It's not true, or will the item actually affect pressure? So this will actually cause a similar pressure being exerted at the same depth. So let's say if I have an object, if I'm actually scuba diving and I'm here, right, the pressure within the same level of the ocean would be the same. We will be exhibiting the same, we will be experiencing the same form of pressure in the water. So when we look at this experiment, which actually shows the pressure is the same at the same level of a liquid, right? We could look at the distance in which the water flows is actually consistent. And of course, the lower the positioning or the height of it, right, you will see that this distance will actually decrease as well. So the liquid spreads out with the same distance and the same speed from these 2 points because the pressure is the same. Okay, as compared to the other one, which is actually smaller. So how then are we able to calculate liquid then, because of all the particles are all in the same direction and things like this? We use this formula called pressure equals to H rho G. Now H represents the depth of the liquid. Okay, not so much, I can say height, but it's more the depth of the liquid. Height will come in when it's a container, and then you will just follow through. Then this rho represents the density. This is density, and G is your gravity on Earth, which is 10. Okay, the gravitational field strength. So to take note the formula, the SI units again, they are different. Depth will be meter, density in kg per meter cube, and then of course gravitational field strength is Newton per kg, which is already 10. So in calculation, right, we are always given, we can always assume the G to be 10 unless the question states otherwise. Density is something that we can calculate. To calculate density, and for liquid, right, it's just basically mass over volume. Okay. Then of course this one mass will look in kg, this one will be in meter cube. Then of course you have your pressure, which is in Pascal or Newton per meter square. Height definitely must be in meter lah. Okay, so in this case, right, the total pressure experienced in a liquid, right, when an object is immersed in a liquid, will experience two different forms of pressure. One, pressure exerted by the liquid itself. Second one is exerted by the atmospheric pressure. So let me give you a very simple scenario of a drinking straw. Okay, so let's say you have a cup of water, and this cup of water you have a straw. Now, then you wanted to drink a cup of water. Now what happens is you can choose to suck the water. Okay, then water will come out. So this is generally in a way like pressure exerting onto in the liquid. However, it will be very tiring and you will not be able to suck that much because of the limited pressure assistance. Hence, there's around us, we are also filled with air particles, and that's why we have the atmospheric pressure or air pressure lah. But more on atmospheric pressure that tends to push this liquid down. So in a sense, when this liquid is being pushed down, you could see that the only way that it can move away would be through the straw and then into your mouth. So that's where they actually say that total pressure experienced in a liquid comes in two forms. Number one is the atmospheric pressure that it's experiencing, and the second one is the pressure exerted by the liquid. Like for example, if let's say atmospheric pressure is low in the air, what will happen is you will see that the sea level and everything, the pressure will be lighter because everything will be moving upwards. There's lesser particles pushing down against the liquid level. Okay. So the total pressure experienced by this object is the sum of both pressure, and this one is something that a lot of students tend to forget. They always, if the question always asks what is the pressure at point X, then they will just calculate this based on the liquid. They tend to forget the atmospheric pressure. Okay. So in this case, like calculate the pressure on the water on a board at a depth of 2 meters and take the density as this. So what we can see, right, is basically just putting in the formula. Very, very straightforward, and just to test for the concept of liquid. However, when it involves an environment that has both, the atmosphere as well as by the liquid, right, we could see that the calculations would be a bit different already. So calculate the pressure that the liquid A exerts on the object. P equals H rho G. You get the formula, you get the answer. The object is now placed in liquid B, at which the depth must the object be placed that it experiences the same pressure exerted by A. Basically, because of that, right, you have to exert the similar, so it must have some equal sign. So what you do is you just sub in the value. You have density of B to be over here looks like 800. Yeah, 800. Okay, and therefore you can substitute to find out the value of H. Okay, very straightforward. Okay, next we look at the transmission of pressure in a liquid. Now, in order for these to take place, right, the assumption is that this is actually a closed system, meaning, right, there's no leakage of pressure and that all the pressure are inside here. So liquid particles, they tend to be quite close with one another, or they're incompressible. Actually, they are non-compressible. But then because if you remember your chemistry, kinetic particle theory, when you draw the different particles, liquid actually have some in terms of particles have some spaces in between them that allows the liquid to actually slide past each other. So generally this helps a bit lah, but not to the extent that you are able to compress tremendously a lot. So when the pressure is actually applied on the piston with a surface area, it will cause some pressure to act on it. And this pressure is then evenly transmitted to all directions of the liquid, causing which it is actually in the Pascal's principle. what this Pascal's principle means is that it's mainly used in the application of the hydraulic system. Okay, one way to actually represent this is your PV equals nRT, which we will discuss later. So for an hydraulic system, right, a device that converts a small applied force into a large force by applying Pascal principle, and then one example is the hydraulic press. In this case, right, what we are talking about, right, the pressure exerted here will be similar to the pressure exerted here, regardless of the size of the shape of the cylinder or the container. Okay, so this will then help us to play around with the parameters. For example, pressure here, you will take into consideration density, that's one. The other one is the force or area of contact and the force. So force can be, let's say you want to do a brake, you want to brake your car, but you do see that to brake your car you need tremendous amount of force. So one way to overcome that is maybe you can adjust the area of the car brakes as compared to the amount of force that you have to actually apply with your leg. Okay, so this will actually consist of two pistols of different size, where a liquid is used to transmit the pressure from a smaller pistol to a larger pistol. So when actually a force is applied at the pistol end, so over here when you apply a force here, you would see that with a smaller surface area, it actually exerts a pressure on the liquid. This pressure is transmitted to the larger piston end, and since the larger piston has a greater surface area, a greater force will be produced. Why? Because you see, right, the formula for pressure is force over area. This is actually a ratio. So being a ratio, right, even though both increase, right, the ratio between it may also remain the same. I give you an example. Let's say your ratio original is 2 over 3. Okay. Then now I increase the pressure to maybe 12 and 18. How would the pressure be different? Actually, both pressure will still be the same because 12 over 18 in the simplest form is still 2 over 3. So even though physical number it increase, however, the overall calculation of pressure is the same because it's actually just a ratio. Okay. Advantage of using a hydraulic press is it allows us to lift a heavy object by applying a smaller force. So this principle is important right here. Okay. We will pause here for now. Do revise, look back at this video and try to understand things that you may not understand. Thank you.